Everybody's favorite thing on number 17. A given, and they want us to prove. So we're going to write a proof two different ways because, like I told you guys before, there are a ton of ways that we can write proofs. There's not one exactly perfect way to do it. So for the first one, I'm going to use Sopoctac, corresponding parts of congruent triangles are congruent. That's going to be the first proof. And the second proof, I'm going to use the third angle theorem. So two ways we're going to get there. So the first one, corresponding parts of congruent triangles. Second one, third angle theorem. So when we write our given statements, make me a nice little T, right? So I've got my statements, and we've got our reasons. So statements and reasons. Okay, we always start with our given, which was angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. That's our given. So if I want to, and what we're going to do, and what I recommend you do, and what will make your lives a lot easier, is we're going to go ahead and we're going to mark this figure with what we know. We know 1 is congruent to 2, so I'm going to go single hoop. And 3 is congruent to 4, so I'm going to go double hoop. We also know, even though they didn't give it to us, they still gave it to us because we're a smart cookie. We know that this angle is congruent because it's a shared side. So we're going to go number 2 is KM, I wrote over my little letter there, didn't I, is congruent to KM. And that's the reflexive property. The wow, is that how you spell reflexive? The reflexive property of congruence. You guys can't even see that, can you? You knucklehead. Okay, so I've got 1 and 2, 3 and 4, so that's an angle, and then another angle, and then we just proved a side. So we've got two options. We've got angle, side, angle, or angle, angle, side. What we're going to do is we're going to go back to our image. We see that our congruent segment is touching both of its congruent angles. So we're going to say that triangle JKM is congruent to triangle ILKM. And that is based on the side angle, or angle, side, angle. All right, because we concluded that, all right, here we're going to stick with different colors here. We'll go purple. Because we've just proven our triangles are congruent, I can now state that these two are congruent. So I would say KJ is congruent to KL, because if my triangles are congruent, all of my corresponding parts are also congruent. So that would be CP, CTC, or on my math lab, I believe it had Sopoctac. So just to stay on brand and consistent what we're doing. Hey, now it wants me to prove. I'm ready to pop that proof statement in there. We'll go with light. What do you want? Pink? Pink sounds great. Nothing orange. So now I can conclude, because I just showed that it's got congruent sides, JKL is isosceles and that's the definition of isosceles. I got two congruent sides. That's an isosceles triangle. So that's my first way. That's using corresponding parts of congruent triangles are congruent. I'm going to wipe off my figure, so I know you're going to get mad at me, but that's okay. And we're going to now use the third angle theorem. So our statements and reasons are going to start off the same. Again, we're going to take this little feller out yonder, make me a nice little T. Didn't do a very good job there, did I? Let's see if we can slide it over just a little bit. So I got statements. And I got reasons. Okay, this time again, we're going to use the third angle theorem. So 1 is going to be angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. And of course we learned that from given. Well guys, if I look at this figure, okay, I'm looking at my triangle, and I know 1 is to 2, and, let's go red. 1 is to 2, 3 is to 4. Okay, because this triangle can only add up to 180, I can also conclude my third angles must be congruent. So I can conclude that J is congruent to L, solid 3, angle J is congruent to angle L. Why do I keep writing the 3? Got 3 on my brain. Messed up my T-square and everything. J is to L because of the third angle theorem. So now that we've got that, so we've got J to L, I can then conclude, number 3, because my opposite angles are congruent, and I want to jump across my triangle, because my opposite angles are congruent, that means my opposite sides, corresponding sides must be congruent. So there's that KJ is congruent to KL. And that's because of theorem 410 from our isosceles. Congruent sides and congruent angles. So look at there. We almost cut out a whole step from the other one. Right, number 4, I can now conclude that triangle JKL is isosceles because we've shown my two sides are congruent, and that is the definition of isosceles.